So in our previous tutorials, we learned the main principles of object-oriented programming in Python. In this tutorial, we'll go over some other important concepts. Now, if we want our class instances to have some common information about something, for example, a number of currently instantiated objects in the running program, we can achieve this through a shared variable. This is almost equivalent to a static variable in C++. For those who are familiar, for those who are familiar with the programming language anyway. In Python, using the shared variable can be used as follows. So let's escape that. All right, so we're gonna make a class called student. Oops, student. All right, it's gonna be called student. Actually, let's not use this. Class student. It's going to inherit object, the object class, and then we're going to say the following. So quote, 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 student, quote, 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 and then number of students attribute, this is our shared variable, equals 0. And then we're going to define our constructor method for, here we go, self, name, and index. And then we're going to have self.name equals name, self.index equals index, and then we're going to have our shared variable right here. So student.number of students plus equals 1. So every time we instantiate a new student, we'll add number of students. This will increase by 1. So let's do S1 equals student. We're going to call him Pythonsky, and he's going to have the index 1, 2, 3, 4, 5. And we're going to have another student student equals Guido van Rossum. And then we're going to have 35, 6, 7. So now we can access the shared variable in the following way. So we're going to have a print, and then we're going to say, so we have print, and we're going to say student dot number of students, and we're going to say S1 number of students, and S2 dot number of students. And as you can see, in all cases, in all instances, it's 2. So another important concept in OOP is a destructor. Destructors are of great importance when it comes to memory management. An example of this is when we use the following operator. It's called del. As you can see, it's highlighted in pink, delete. For example, if we want to delete one of the students and print out the number of students, we will see the result is incorrect. So we're going to do this. So we have our initialized students instances, and we're going to say delete. We're going to say delete S1. Oops, S1. And then we're going to print now the number of students. Number of students. As you can see, it's still 2, but we deleted 1, so it should be 1. So the purpose of the deconstructor is to release the resources and ensure the adequate functioning of the program. The destructor for our class should be decrement the number of students when a student is deleted. So we have to add another method. In this case, we're going to define a new method. It's going to be for del. And we're going to say self, and it's going to be student dot number of students minus equals 1. So every time you use a destructor, it's going to decrement this value. So now, when we actually do this, it's going to be 1. And destructors are mostly used for memory management. However, in Python, we don't really have to worry about this because there's a mechanism called the garbage collector, which is used for managing memory. And that's pretty much it.